Math 99. Today we're starting section 5.2 on page 350. And I guess we could think of this as continued review of 5.1. We're factoring polynomials. Today we're going to factor a special polynomial of the form or pattern that follows x squared plus bx plus c. Now our leading term is a squared term, x to the first degree, and then x to the 0 degree. That's our constant. X squared plus bx plus c. And we're told that if we have this form, which we want to recognize, we should be able to factor it as the product of two binomials. And that sounds familiar to me. We've been looking at multiplying two binomials for a fair amount of time now. So if I have the form x squared plus bx plus c as a polynomial factored, I can expect to factor it as a binomial times a binomial. The square of a sum is a binomial times a binomial. The square of a difference is a binomial times a binomial. The product of a sum and a difference is the product of a binomial times a binomial. So again, our blue cards are going to come in very handy. Remember, this is our polynomial, sum and addition of monomials. This is our factored side. I have something times something. We're predicting a binomial times a binomial. So your directions are going to be factor, and we're given x squared plus 5x plus 6. I have my form pattern, x squared plus something times x to the first degree plus a constant. We expect we can factor that as the product of two binomials. So let's see. Oh, I can take the first term. I'll be x. Think about FOIL now. The first term, x times x, would be x squared. So I've got the first term covered. But how am I going to manage to factor the next two terms? Well, remember the game that we played? We were looking for factor pairs of the constant 6. And it's positive 6. Whose sum is the coefficient on the x to the first degree term, which is a positive 5. We played that little game. I'm looking back. Oh yes, page 314. So our little game we played was on page 314. So we know how to factor 6. That'd be 1 times 6, 2 times 3. A negative 1 times a negative 6, still be positive 6. Negative 2 times a negative 3 would still be a positive 6. So I found factor pairs of positive 6, but I want to add the factors to get a positive 5. 1 plus 6 is not 5. 2 plus 3, 2 plus 3 is equal to 5. So there's your factor pairs. And you simply write them in, a positive 2, positive 3. And we factored x squared plus 5x plus 6 as the product of the binomial x plus 2 times the binomial x plus 3. Well, let's check. I have x plus 2, the quantity, times x plus 3. So again, that's my blue cards. Are the first two terms the same? Yes. Are the last two the same? No. So I'll have to use FOIL. X times x is x squared. X plus 3 would be plus 3x. Inner terms plus 2x. And my last terms will be 2 times 3 is 6. Remember, with FOIL, we expect that we can collect those like middle terms. X squared plus 3x plus 2x is 5x plus 6. X squared plus 5x plus 6. You can circle your answer. Yeah, Elias, I'm at 506 and I have one site. No one's there, but there's background noise. If you could check that out, please. Thank you. So we'll be following this pattern now as we're factoring polynomials of the form pattern. X squared plus bx plus c. So we have our form pattern, x squared plus bx plus c. X squared plus something times x plus our constant. We expect we can factor it as the product of two binomials. So we're asked to factor y squared minus 8y plus 12. Y squared minus 8y plus 12. Well, we recognize that this is of our form pattern, y squared plus something times x plus c. So we're going to try to factor that as a product of two binomials. Now we need to recognize that our middle term is y squared. Change subtraction to addition and add the opposite. So now we know the sign of the coefficient on the middle term. And still, we expect to factor that as a product of two binomials. Oh, let me take the first term. Y times y would be y squared. But we're going to need to build our factor table. We need to factor pairs of our constant, which is positive 12, whose sum is the coefficient on the x term. Well, factor pairs of 12, we have 1 times 12, 2 times 6, 3 times 4, 5, 6, okay. We have a negative 1 times a negative 12, of course. A negative 2 times a negative 6. A negative 2 times a negative 6 would be positive 12. And when I add my factors, a negative 2 plus negative 6 is negative 8. So I have my factor pairs. I simply fill them in. So let's check our answer. We have y minus 2, the quantity, times y minus 6. That's a binomial times a binomial. Let's check our blue cards. Are the first two terms the same? Yes, but the last two terms are different. So I will just have to use FOIL. Y times y is y squared. Y times a negative 6 is a negative 6y. My inner terms will be a negative 2y. And my last terms, a negative 2 times a negative 6 is positive 12. With FOIL, we expect to collect those like middle terms. Y squared, a negative 6y plus a negative 2y would be a negative 8y. y squared plus a negative 8y plus 12, our original y squared minus 8y plus 12. You can circle your answer. Factoring a special polynomial of form x squared plus bx plus c. We expect that we can factor it as a product of two binomials. Think about FOIL, first, outer, inner, last. We look for factor pairs of the constant term whose factor pair sum is the coefficient on the middle term. Supposed to factor x squared minus 8x minus 20. Well, I'm factoring a polynomial, but it looks to me like it's of the form x squared plus something times x plus a constant. We expect we can factor that as a product of two binomials. Oh, let me take the first term. In FOIL, the first term x times x would be x squared, so I've got that covered. I think it'll be okay.
Okay.
Because online they can see me,
Okay.
but in that classroom they can't. There's a way there.
Okay.
Oh, oh, oh. I don't have time for that. Okay, let's build our factor table. We're looking for factor pairs of the constant. By now, we should be able to recognize that this is negative 20. Change subtraction to addition and add the opposite. If you're not comfortable with that, be sure to physically change subtraction to addition and add the opposite. We're looking for factor pairs of our constant, which is negative 20, whose sum is the coefficient on the middle term, which again, we should be comfortable now to recognize that this is plus the opposite, so it's a negative 8 as a coefficient on the middle term. So negative 20, that'd be a negative 1 times 20, 1 times a negative 20, 2 times negative 2 times 10, 2 times negative 10, 4 times negative 5, negative 4 times a positive 5. We're looking for the factor pairs whose sum is negative 8. Well, it's not that. Here's a positive 8. Here's our negative 8. 2 plus a negative 10. 2 plus a negative 10 is negative 8. We found the factor pairs of negative 20 whose sum is negative 8. Remember the game that we played on page 314. You might want to review that again. So I can simply fill in plus 2 minus 10 and check with FOIL. With FOIL, the first terms, x squared. Outer terms will be a negative 10x. Inner terms, positive 2x. And my last terms, negative 20. With FOIL, we expect to collect those like middle terms. So I get x squared. Negative 10x plus a positive 2x would be a negative 8x minus 20. X squared minus x minus 20, you can circle your answer. Okay, we're continuing to factor. We're given t squared minus 24 minus 5t. Well, let's arrange to some order. T squared minus 5t minus 24. So we have our leading term and our next agreed term and our constant. And now I see that I have the form pattern, x squared plus something times x plus a constant. So I'm going to factor that, hopefully, as the product of two binomials. Oh, let me take the first term. T times t would be t squared. Remember FOIL, first terms, outer terms, inner terms, last terms. So I've got t times t would be t squared, but we'll have to build our factor table. Factor pairs of a negative 24. Factor pairs of your constant, whose sum is the coefficient on the middle term. Now the coefficient on the middle term, remember this is subtraction. If you need to physically change subtraction to addition and add the opposite, or if now mental math, you know that it's a plus a negative 5 times t, you have to control the sign. And the coefficient on the middle term is a negative 5. So we're looking for factor pairs of negative 24. That'd be a negative 1 times 24, 1 times a negative 24, but I'm pretty far away from 5 when I'm adding. The range is extreme. So let's look for factor pairs that are a little closer together. So I have 2 times 12. Let's see, a negative 2 times 12. 2 times negative 12, and that's 10, looks like. Getting closer. Factor pairs of negative 24. How about 3 times a negative 8? 3 times a negative 8 is a negative 24, and 3 plus a negative 8 is a negative 5. There's my factor pairs, and I can fill in. So let's check. T plus 3 times t minus 8. Well, that's a binomial times a binomial. Let's get out our blue cards. Are the first two terms the same? Yes. Are the last two terms the same? No. So I'll resort back to FOIL. First terms would be t squared. My outer terms are a negative 8t. My inner terms are a positive 3t. And the last terms are a negative 24. So I have t squared, a negative 8t plus a positive 3t, be a negative 5t minus 24. A negative t squared minus 5t minus 24, or t squared. This is the opposite of 5t. Remember, drop the sign and change addition back to subtraction. So that is correct. We can circle our answer. Your directions say to factor. X to the fourth minus x squared minus 1/10. I don't recognize any pattern that I have yet, but how about x squared, the quantity squared would be x to the fourth minus 1 times x squared minus 10. Now I have a base squared plus something times a base, but x is x squared plus my constant. So I expect I can factor this as a product of two binomials. So to get back to my form, we let x equal x squared. So x is x squared, I'm squaring it, plus something times x, but we let x equal x squared. And then your constant. So, oh, I can do the first term. X squared times x squared would be x to the fourth. But we'll have to build our factor table. And we're going to factor our constant, which is a negative 110. And I want to factor negative 110 and find the factor pairs whose sum is the coefficient on the middle term. Now the coefficient on the middle term is, remember, change subtraction to addition, add the opposite. It's a negative 1. The sign of the term is tied up in the operation of subtraction. Change subtraction to addition and add the opposite if you need to. So factor pairs of the negative 110. Well, that'd be a negative 1 times 110. 1 times a negative 110, but I'm quite a ways from 1 again. I'm looking at my extreme range of factors. How about 10 times 11, isn't it? Yeah. 10 times 11. But I'm looking for a negative 1. So 10 times a negative 11 would be a negative 110. And 10 plus a negative 11 be a negative 1. So there's your factor pairs. So you have plus 10 and minus 11. Let's check our answer. We have x squared plus 10 times x squared minus 11. That's a binomial times a binomial. I'm going to get my blue card out. Are the first two terms the same? Yes. Are the last two terms the same? No. So we'll resort again back to FOIL. First terms be x to the fourth. The outer terms will be a negative 11x squared. The inner terms plus 10x squared. And my last term, 10 times a negative 11 is a negative 110. We expect with FOIL that we can collect those like middle terms. A negative 11x squared plus a positive 10x squared would be a positive 1x squared minus my constant. X to the fourth minus x squared minus 110. We can circle our answer. Asked to factor a squared plus 4ab minus 21b squared. Well, that looks like we are collecting like middle terms that are going to be ab, and the square root of a here and the square root of b. So we expect that we can factor this as a product of two binomials. something times a, I guess we're looking at a squared, let's do it that way. A squared plus something times a plus our constant. Looks a little bit different. We need factor pairs of our constant. And our constant is negative 21b squared. We're looking for factor pairs of a negative 21b squared whose sum is the coefficient of the middle term, which is going to be 4b. Well, we have a negative 1b times 21b. A negative b times 21b would be a negative 21b squared. But if I add those two, I'm going to get a positive 20b, not quite what I'm looking for. How about positive 3b times a negative 7b? 3 times a negative 7 will be negative 21, and b times b is b squared. When I add, I get a negative 4b. Not what I'm looking for. I'm looking for a positive 4b. So how about a negative 3b times a positive 7b? Negative 3 times 7 is a negative 21, and b times b is b squared. So there you go. 4b, a negative 3b plus a positive 7b is going to be our positive 4b. So there's your pattern. So I can fill in my first term, a and a, give me a squared, and then a minus 3b plus my other factor of 7b. And now let's check. I have a minus 3b times a plus 7b. That's a binomial times a binomial, so I'm going to get out my blue card. Are the first two terms the same? Yes. Are the last two terms the same? No. So we'll resort to FOIL to solve. First two terms are going to be a squared. Outer terms, a times 7b is going to be a positive 7b. Inner terms, I have a negative 3. A times 7b will be a 7ab. Inner terms, a negative 3b times a is going to be a negative 3b times a, or ab. In my last terms, a negative b times a positive 7b is going to be negative 21, and b times b is b squared. Let's check. I have a squared. We expect we can collect those like middle terms. A 7ab subtract 3ab would be a positive 4ab minus 21b squared. A squared plus 4ab minus 21b squared. Sure enough, I was able to factor that polynomial of the form ax squared plus something times a plus constant as the product of two binomials, a minus b times the quantity a plus 7b. Then we have x squared minus x plus 5. And we're supposed to factor. Well, it's x squared, so sure enough, x squared plus something times x plus our constant. That's our form pattern that we're studying today. And we expect we can factor that as a product of two binomials. Let me take the first term. X times x in FOIL would be x squared. Then let's build our factor table. We need factor pairs of the constant, positive 5, whose factor pairs sum is the coefficient on the middle term. Careful. X squared, change subtraction to addition and add the opposite. So this is a -1 times x. We're looking for the coefficient on the middle term, which is a -1. So factor pairs of 5. Well, 5 is prime. That's 1 times 5, or a -1 times a -5. There are no other factors of 5. This, when I add, is 6, and this, when I add, is a -6. It does not equal -1. So this is an example of it's not factorable in the real number system, which we're working with right now. So there are those polynomials of the form x squared plus bx plus c that are not factorable. And kind of a tip or a hint, when you see the prime numbers, you know that there's a limited number of factors for one thing. And so it reduces your number of factor pair combinations to provide the factor pair whose sum is. So we had a reduced number of factor pairs. We could check them easily, and there's no combination where the factor pairs sum is equal to a -1. So this is an example where it is not factorable. Special case, but we need to recognize. Wait, we're asked to factor. 2x cubed minus 20x squared plus 50x. Well, obviously this is not of our form pattern that we're discussing, x squared plus bx plus c, but we should always look for a greatest common factor. I'm on the other side of my blue card, and we have factoring strategy to factor a polynomial. And it says always, 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 always look for the greatest common factor. And if there is one, factor it out right away. So let's see, is there a greatest common factor? Well, 2 for sure. X to the first degree. 2x. 2x times what would give me 2x cubed? X squared, pick up your sign. 2x times what would give me 20x squared? Pick up your sign. And 2x times what would give me 50x? 25. So distribution in reverse. I factored out my greatest common factor, which is 2x. I have 2x times a polynomial, and it looks like this polynomial is of the form x squared plus something times x plus c, which we expect we can factor as a product of two binomials. So I'm going to build my factor table. Factor pairs of the constant, positive 25, whose factor pairs sum is the coefficient of the middle term. Looking carefully, manage your sign. Remember, this is a -10 as a coefficient. So we're looking for factor pairs of positive 25 whose sum is -10. Well, that's 1 times 25, a -1 times a -25. Sums aren't close yet. Let's see, 5 times 5 is positive 25? How about a negative 5 times a negative 5? Negative 5 times negative 5 is a positive 25, and when I add a negative 5 plus a negative 5, I get negative 10. So there's your factor pairs. Now we were following strategy to always look for that greatest common factor, and we did. But don't forget to carry your greatest common factor along as we factor the trinomial. So we're factoring the trinomial now as the product of two binomials. And we're thinking of factoring, we're factoring our trinomial, and a common mistake is to forget or drop your common factor. So we have the common factor out in front. We're going to factor this as the product of two binomials. Our factor pairs are a negative 5 and a negative 5. We might want to recognize that this is 2x times x minus 5, the quantity squared. So let's check. I have 2x times x minus 5, quantity squared. Well, that's a binomial times itself, and it's a binomial times a binomial, so the first two terms are going to be the same. The last two terms are going to be the same, so my pattern is a squared plus minus 2ab plus b squared. So I can factor this as a squared minus, collect two like middle terms, and square the last term. So I have my greatest common factor times the first term squared is x squared, minus 2 times the first term is x, last term is 5. And I'm going to square the last term, which is 5 squared. That's our special product rules for the square of a sum and the square of a difference. 2x times x squared minus 2 times 5 is 10 times x plus 25 squared is a positive 25. And now I have distribution. I need to distribute 2x times the first term, which is 2x cubed. Pick up your sign and distribute 2x times 10x. 2x times 10x would be 20x squared. And distribute 2x times 25. 2 times 25 is 50x. 3x cubed minus 20x squared plus 50x. Okay, we're going to stop again today. We are working on homework and testing, and this chunk of material is so very important. We will come back to it. I've shown you from entry level to intermediate level to kind of an advanced level of factoring the polynomial of the form x squared plus bx plus c, and we need to rehearse this a bit more before we move on. So we'll be catching up and reviewing with our entry into chapter 5 next week. Please check the overview document at MyMathLab because we are testing and have homework assignments at MyMathLab with their due dates. So thank you very much.